So here I'm told that the perimeter of a right-angled triangle is 72 centimetres. And I'm also told that the lengths of its sides are in the ratio 3 to 4 to 5. And I'm asked to use this information to work out the area of this triangle. So I think a good place to start here would be just drawing a quick diagram out, just so that I can definitely see what's happening. I know that I'm working with a right angled triangle with sides in the ratio 3 to 4 to 5, and the greatest length, so this one represented by the 5 in the ratio, is going to have to be the diagonal of this triangle, as that's going to have to be the longest length. So if I draw out a triangle like so, we can see that this longest diagonal length is going to have to be the greatest one, and then the two side lengths are going to be represented by the 3 and the 4 in the ratio. So I can just start by labelling the sides of the triangle up with the values in the ratio. So if we go 3 to 4 to 5, and so we have a base triangle to work with here. Now we're told that the perimeter of the triangle is 72 centimetres. So there's got to be a way we can scale up this ratio of 3 to 4 to 5 to have these side lengths sum to 72 centimetres to be the perimeter of this triangle. So if I take 3 and add on the 4 and the 5, that's going to give us a value of 12. And then I can take the 72, which is the perimeter of the actual right angle triangle, and divide it by the perimeter of this triangle that I have here to see how much each side length needs to be scaled up by to get to the right angled triangle with a perimeter of 72 centimetres. So this here gives me an answer of 6. So now I know that each side length of this triangle has to be scaled up by a factor of 6. And in order to work out its area, I need to take the base length, so this length here, and multiply it by this length here, and then divide that answer by 2. So if I take the 4, now that's going to be multiplied by 6 to get the actual length, so that gives me an answer of 24. I can then take the 3 as well, multiply that by 6 to get the new length, and that gives me an answer of 18. And now I have the two side lengths that I need to work with of the new triangle. So to work out the area here, I'm going to take 24, multiply it by this 18, and then I need to divide that by 2 to find the area of the triangle. And that is going to give me an answer of 216. And as for the units here, we can see that we're working with centimetres squared, and we can just check this because we know that each side length is now going to be in centimetres, and we're multiplying centimetres by centimetres, so that's going to get us centimetres squared here. Now I can simply write my answer in the box, and that is going to gain me all 4 marks for this question here. So if I have a look back through how the marks were awarded, so the first mark was for working with the ratio and finding this value of 6, by which they all need to be multiplied up by in order to achieve the side lengths of the actual triangle, not the kind of scaled down version shown by this ratio in its simplest form. And then the second mark here is for finding the length of either the base or the height of the triangle, so one of these, either this calculation of 24 or the calculation of 18 here, will get me the second mark. And then finally, this last step of working out the area of the triangle, so using the formula base times height divided by 2, that's going to get me the third mark. And then the fourth and final mark here is just awarded for the correct final answer of 216.